we're completing the table and switching in between exponential form and logarithmic form. This is something that we should be able to do super quick, and if you can't, we're just going to keep practicing it until you can do this really quickly. So we're going to take the base, so we're switching from exponential to log, so we have log, and the base is 4 of the argument, which is 64, equals the exponent. So log base 4 of 64 equals 3. That's how we read that. So the next one, it is log base 10 of x equals 35. So we start with the base, which is 10. Our exponent is 35 because the answer to a log is just an exponent, and that equals our argument, which is x. And you see how useful that would be to be able to switch back and forth, because now we can figure out what 10 to the 35th is and find x. If we convert this one into log form, we have log base 6 of our argument, which is 1 over 216, equals our exponent, which is -3. The next one is log base e, because it's ln, of 3x equals 8. So we're going to go, our base is e. The exponent is the answer to the log, which is 8. I can't remember what colors I'm using, even though they're like right in front of me. Equals 3x. And again, do you see how useful this would be to be able to switch back and forth? Because now if we wanted to find x, we could just put e to the 8th in our calculator, and we could divide by 3 and find our answer. All right, so this would be log base 1000 of our argument. See, I keep like, even though I know, of our argument, which is 1, equals our exponent, which is 0. Switching the colors is really making it hard. I'm like trying to keep up with the colors. I don't know how some of these like awesome YouTubers do it. It's like really hard for me to like talk and remember what color I should be using, even though it's like literally right in front of me. Okay, so the final one, we have our base is 5. Our exponent's going to be the answer to the log. So that's going to be 1/2. And our argument is going to be square root of 5. Okay, so what happens if we have more complicated exponents? Can we still switch them around? Yes, we can. You may have seen this on Delta Math. It's actually not too bad. So we have a base, we have an exponent, and we have an argument, right? So let's just switch this around. So this is going to be log base 10 of our argument equals our exponent, because the answer to a log is just an exponent. Okay, so now we could actually solve this, couldn't we? We could just plug this into our calculator, but x isn't quite by itself, so let's get x by itself. So log base 10 of 25 is just a number. It's a number we could put into our calculator, but we need to add 1 to both sides. So I'm going to write it in front. So I'm going to add 1 plus log base 10 of 25, just because if I tried to put it in the back, if I tried to write it like this, log base 10 of 25 plus 1 equals x, many of you would be tempted to add the 25 and the 1 together, right? But we have to remember that this is a function. This whole thing right here, this is a function. This is log base 10 of 25. It's one big thing that's all together, right? It's a function, and we cannot add across a function, right? Because functions take precedence over little things like adding, okay? So I'm just going to add the 1 to the front. Now we can just plug this into our calculator. Let's pull our calculator up. And we could say 1 plus log. Now remember, the log in your calculator is log base 10. So if you're trying to do a log any other base, it doesn't work. But if you want log base 10, you can just use the log button in your calculator. Log 25 equals 2.3979. So that whole mess. So I'm going to write that down. 2.397940009. Okay, so how do I know if this number is true? How do I know if this number even is the number that makes this whole thing true? You guessed it, we could plug it back in, right? And get this number, and I say, if I take this ridiculous number and I subtract 1, and then I raise 10 to that number, I should get out 25. So let's see. Okay, so 10 to the x, this is our x, right? X minus 1. So I just went and used that number. I didn't round it, because if you round it, you're going to not get the right thing, because exponents grow so quickly that rounding really screws them up. So if I push enter, look at that, 25.000002. Now remember, calculators are really terrible rounders, so that's why I got that 02 there, because it's like rounding off. But really, that's right? 2.39794 makes my equation true, therefore it is x.